Okay, using the difference quotient to find the slope of the tangent. Definitely saw this in advanced functions, but now we're going to get a little deeper on the whole thing. Here's the first example. Consider the function f at x equals root x plus 7x minus 1. Determine the slope of the secant from the point where x equals 1 to the point where x equals 9. Well, I'm going to draw a little picture. I'm not going to pretend I know what root x plus 7x minus 1 looks like in my head. And I don't really need to visualize what I'm looking for. So just imagine that in part A, this function looks something like that, you know, some kind of curve. And maybe you remember this from advanced function, me just drawing a random curve to go, okay, this thing's curved up, it's curved down. I don't really care. What I'm trying to find is the slope of the secant. That is, they've given me the first x value, and they've given me a second x value, and that's enough to visualize what I'm looking for in a secant slope. And in a second, I'm going to ask you what that represents in real terms. You know what I mean? So you think about that for a second if I'm just going from this x value to that x value. Now, it said slope of the secant. So I've got the 2 points I need. That is, this point is x comma, x is 1 comma something, and this is 9 comma something. And by the time I draw that, hopefully you're like, wait a minute, this is just finding slope. Finding slopes of secants is just what you were doing the whole time. The only difference is it's not on a line, it's on a curve. It's just saying what's happening from here all the way over to here. I'm trying to lay enough hints that you know which rate of change this is called by the time I finish. So to find the slope of the secant, I'm going to label it carefully. I'm really just doing y2 minus y1 over x2 minus x1. And they've given me the two x values here. That's the nice thing about secant slopes. You've always got both the points, you know, and so now you're just finding the slope between them. And so, okay, I'll take a second and sub those values in. When I sub 9 in, let's see, f at 9 is root 9 plus 7 times 9 minus 1. I almost wrote plus 1 there, minus 1. Let's see if I can do this in my head here. 3 plus 63 minus 1 is 65. So the second y value is 65. Let me fill that in on my picture here so you really get the idea. So that's a 65. Now, find the f value at 1. And so it's root 1 plus 7 times 1 minus 1. I think I get 7 there simply. Not too complicated a situation. This is the kind of stuff you put on that first page of the test, you know, where it's like no calculator. You're like, oh no, no calculator. And then it's like, okay, all pretty straightforward numbers. So that was a 7 over 9 minus 1. 65 minus 7 is 58 over 8. And maybe I could reduce that down a little bit to 29 over 4. That's the slope of the secant. What other set of words did we use to describe slope of secant? The average rate of change. So when you're looking at, I've got both x values, I want to know what happened over some time period. And it's just the average rate of change across there. So average rate of change, very simple. The grade 9s could do it. You know, they knew how to find y2 minus y1 over x2 minus x1. So that wasn't the complicated situation. B, here's the complicated situation. Determine the slope of the tangent at the point x equals 4. And I'll let you think about it for a second, about what we're talking about, what type of rate of change we're talking about with 4. I'll let that bounce around your head. Hopefully it's already home. But I'll let that just sit there for a second. And I'm just going to rewind back to the advanced function lesson on this that went on forever. I mean, it was the longest lesson you'd ever seen at that point. You know, I think I actually went over a full period trying to teach this whole thing, right? And instantaneous rate of change is difficult because you only have one time. Find the instantaneous rate at time 1. I mean, this is easy when you're in your car. Your car's really good at instantaneous rate of change. It's got the speedometer right there telling you how fast you're going. Well, that's the only place ever that instantaneous rate of change is easy. Because they only give you the one time. You're like, well, I want to find slope here, but how do I choose another time? And so what we did, shockingly, It was shocking when I went to do it. You go from 1 to 2, 1 to 1.5, 1 to 1.1, 1 to 1.01, 1 to 1.001. Keep going to time periods. You choose the second time period, but get so close that you see what's happening with the slopes. You have to do this table long enough that you see where it's headed towards. Now we got the word for it, so that we can see what the limit is as we head along there. Now, we did this method with the tables, and I did enough of them in the homework to hopefully horrify you and torture you into going, okay, I get what's happening. And all of that was leading to understanding what limits were. Where is it heading towards? So all that's not wasted time. We're just glad we don't have to do that kind of thing anymore. That was trying to find, when you were doing that, we were trying to find the slope of the tangent, which we called instantaneous rate of change. I've given it away now. And, okay, so we did it with tables like crazy. And then later on, I showed you, here's that tangent slope summary, which if you're dying to have it, I'll get it for you, but hopefully we're going to get past this. I said, okay, method 1 was the chart method. Easy to do, long and boring. Yeah? Then I showed you method 2, which was the secant slope formula. And I'm going to reteach that in a minute. Then I'm going to be done with it forever as I teach you method 3, which we mentioned in advanced functions, but I said, you know what, don't worry about it. It's called the difference quotient, and that's in the title of your lesson today, and I'm going to go back and do that third method. This third method, much more powerful than the other two. Okay? So we'll get to that in just a second. Back to here. I'm going to do this example that I just talked about, the difference quotient. I'm going to do this one with method 2, not with the table. I'm trying to get ready for method 3 here. So the idea in method 3 is that you have some point, and I'm going to do the curve the other way this time just to prove I don't really need this picture. Well, I do, but I don't really care what it looks like. This thing could be curving up, curving down. The math will take care of all that. The picture is just to go, let me just visualize 2 points and what's happening here. So what we do with this one is we have our initial point, 4 comma, they didn't give me the y value. Hopefully we can find that pretty easily in just a second. And then I'm going to have some other point out here. But I'm not going to announce what that point is. That was the thing about method 2, is I'm going to say, I don't know, I'll decide later. Maybe I'll ask somebody, Mr. Tao, what point do you think I should use? Something like that. So for now, I'll just call this x. And then it's tempting to write a y there, but we don't. We're trying to keep this as simple as possible. Maybe that ship has already sailed. But to understand what goes here in the second point, I want to talk about what goes here in the first point. If someone said to you with this homework and said, Mr. Todd gave me x equals 4, but I don't know the y value, what would you say to them? Yeah, just put the 4 into the equation. And that's a major league big point in all this. So I'm going to sub in 4 in there. Let me just put that over here. F at 4 will be root 4 plus 7 times 4 minus 1. So I get 2 plus 28 minus 1. I get 29. That's not supposed to be difficult. It's supposed to be like, yes, of course I know how to get the y value. I just sub it in there. Now, so then when I go to find the y value of this second point, it's the same thing. Just sub in x. And that's weird because people go, what do you mean sub in x? And I say that's what the equation is. The equation is x subbed in there. So this is what you do. Root x plus 7x minus 1. That is, you're telling somebody, once someone tells you what x value to use, like let's say you're waiting for me to tell you, I didn't know what x value to use in question B, or in part B, and you're waiting for me to tell you, you're like, okay, once he tells me, I put it there, and then to get what goes there, I just take whatever number he tells me and go root x plus 7 times x minus 1. So it's really not that complicated what's going on here. You're saying, okay, once you get the x value, then sub it in to get the y value that goes with it. And now here's the secant slope formula. And I hope at this point you're either completely like, yeah, but we were supposed to find slope of the tangent. Why are you finding slope of secant? You're either thinking that, or you're like, oh, I know exactly what has to happen next if I'm finding slope of tangents. Because it's the key to the whole lesson. If we get what I'm about to do here, method 3 will not be difficult, except for the algebra. The algebra will be, that's what we'll work on the rest of the way. The idea won't be hard. So we made a secant slope formula. And I'm going to write the lines here. Slope of the secant is always just y2 minus y1 over x2 minus x1. That's always true about slope of the secant. But the slope of the secant here is weird looking. Root x plus 7x minus 1 is the first. Sorry, it's the second y value. This is in the way now. I'll just put it over here. And then the first y value is 29. Second x value is x. First x value is 4. And what I get is a secant slope formula that I can use. Root x plus 7x minus 30 over x minus 4. Now, that's slope of the secant. Again, I said, hopefully you're either thinking, yeah, that's fine, but you want slope of the tangent, or you're like, I know exactly what to do. If you're in one of those two places, we've set this all up through advanced functions all the way to this moment to be in great shape. You're either thinking, that's the slope of the secant, I don't want that, I want slope of the tangent, or you're thinking, I know what to do next here. What do we do next here to get this as slope of the tangent? Sub in a value close to 4. That's step 1. I'm going to start doing what she said. And then there's a step 2. You know, like it's a long step 2. So I build my table. I still build a table in this method. You say, I thought this wasn't the table method. Well, it's not the table method. It's like a shortened version of the table method. Instead of all those columns that were in the table, back to my old lesson here, instead of all of these columns that were in the table, we're just going to take the x value and jump right to the slope of the secant. We're going to jump all these steps over. So it really is the same table method with a shortened version of it. And I've lost where it is. Is it here? There. Okay. So we choose some x values, and we've got a suggestion. She says, choose something close to 4. I'm going to choose 4.1, close to 4. Is it close enough? I don't know. I'm hoping it's close enough, but we'll decide as we go along here. And then I just put 4.1 into this whole equation here. Let me get my calculator out and sub it in so you can see what that looks like. I'm hoping most of you have a calculator that handles this easily, but if you don't, that is, if you've got a calculator that displays numerator, denominator, then you don't need the steps I have here. Yeah? And the calculator, you've got the FX, you know, if you've got that one, you're definitely not going to have to type it in the way this one shows. But okay, so hopefully you've got this fraction button, which gives you a display like that. That's what we really hope for in a calculator these days, yeah? So then I just type in 4.1. Okay, so I got to go square root 4.1, leave the brackets, and then plus 7 times 4.1 minus 30, and then the denominator is 4.1 minus 4. When I press equals, I get 7.248. Do you get 7.248? Yeah. Okay, and the only reason we're checking is like, oh yes, I'm able to type these in. I know what I'm doing. That was step 1. She's right. Something close to 4. In my picture up here, I found slope of the secant, but between 2 points that are pretty close. What's next after subbing in something close to 4?
Would you sub in from the other way, so like 3.9?
You definitely could go from the other side. Yeah, and maybe we should go from the other side. And I will talk about that in a minute. We're going to deal with that. Limits is going to take care of all that for us. Something closer to 4. We think this is a good answer. We think those two numbers are close together enough that they're a good estimate of the slope of the tangent. And but what I mean by that is I'm going to draw the slope of the tangent on here. An estimate, like just me sort of on my picture going, what does the slope of a tangent look like? And the slope of the tangent sort of looks like that. You say, well, it doesn't look close at all. I'm like, well, yeah. The idea is now I'm going to choose a point closer to 4. And I'm not going to draw any more diagrams. When I draw diagrams that show a million slopes, it gets a little bit confusing. All I'm going to show is 2 slopes of the secant to totally give you the whole brilliant idea That's actually pretty simple when you think about it. Find the slope of a secant pretty close, and then one that's even closer. And if you just keep doing that, you're going to get closer and closer to the slope of the tangent, which is the limit. You know, where is it heading towards? We hope that one more time will be close enough. The nice thing about your calculators nowadays, and I don't want to sound too old here, is that you can just go back and just go, okay, change those to 4.0 ones. You don't have to retype the whole thing in again. Just change those to 4.0 ones. And I get 7.2498. And you might be pretty confident that you know what the answer is. I'm going to go one more to really hammer the point, the point home here, that once you got this thing set up, it was a pain to set up, but once you do that, then you can just keep getting closer and closer until you feel great about your answer. And I think we're going to feel great after this one. 7.24. Oops. 7.24998. It's definitely heading towards something now. I've got this thing nailed down. Therefore, slope of the tangent is equal to 7.25. I'm going to put approximately because we're still sort of guessing. Is it possible the answer is actually 7.24999, not 7.25? Well, yeah, maybe. You know what I mean? But so that's why I put approximately. 7.25 is a great approximation to this answer. Question?
So half of these didn't go from the other side as well.
Oh, I really should. I absolutely should. Let me finish the lesson, and you'll see that you're like, oh, this is why he wasn't too worried about it. Like, the textbook last year was sort of worried about it. It said, you got to come from both sides. And once on the test, I made you come from both sides. You're like, don't you have to come from both sides? I'm like, yeah, we really do. But just wait till the lesson finishes. And there's a moment where all of a sudden I finish that, and I go, see? Both sides, no problem. Okay, so you don't have to worry about it so much. But great question. Any other questions about this? Let me just say something dramatic that ties advanced functions together with what we've been studying. The slope of the tangent is the limit of the slopes of the secants as x approaches the x value in question. As we get closer and closer, there's a limit going on here. We're trying to find out where is it headed towards. That's not a change at all. In fact, I might have used the words last year. What's the limit here? Where's it headed towards? You know, and I might have thrown that in there going, just set the table for next year. And so the idea here, if you're like, I think I totally get the idea here. Yeah, I don't think the idea is too complicated here. Well, once you get it. I mean, it took a while to develop, but once you get the idea. Okay. But I'm only going to do it 1,000 times more. So even if you're still having trouble with the idea, I'm just going to do that. Basically, the rest of this lesson, I'm going to do this 46 times now, or however many times it is, in all sorts of different situations, with a new look at it. Here's the, we would need this one live because it does some animation. This is the whole reason PowerPoint's involved here is because there's a little animation here for this example here. Recall our method for finding slope of the tangent to a curve at a point P. Determine the slope of the secant line from P to another point Q on the curve. Repeatedly move Q closer to P each time calculating the slope of that secant. Giant pain it's been in the past, right? You know, we're on our way to making this less painful. Repeat this process using points on the other side of P. That's what Luke said there was, shouldn't we come from both sides? And the answer is a big yes. And then now, changing the phrasing of the last word here. This isn't what the advanced function version of this said. It didn't use the word limit. It says, see where it's headed towards. It says, use the limit of the secant slopes to approximate the slope of the tangent. And here's the animation. You got a point P there, go to a point Q this way and a point Q that way, do it from both sides, and keep moving those Q's closer and closer until you can see exactly what that slope of the tangent must be. Method 3, the difference quotient. More power here. You're going to see within a week, you're going to be like, you know what? It'll be perfect if by the end of the week, you're angry with me. You're like, why didn't you just make us do this from the beginning? And it's a good question. But the answer is, I wanted you to really understand what limits were, how things approach things and head towards the answer. Difference quotient. Here, just a different look, a slightly different view on the same idea. Suppose we want to find the slope of a tangent at a point P, where P has the coordinates a, f at a. That may look complicated, but all I'm saying is you get an a value, and you sub it in to get the y value that goes with that particular a value. So that looks complicated, but in practice, it's not actually complicated to do, to find the x and y pair there. Now, consider another point in the curve moved over a little bit. We're not going to go too far over. We don't want to get too far away from this. 4 to 4.1. And we're going to call that x value a plus h. And for us, all through this next chapter or so, h is always going to be a little bit. H is like the 0.1 or the 0.01 that you moved over. So this a value plus a little tiny bit. Yeah? So that's what h represents, a little tiny bit. What's the little tiny bit? Well, I don't know. Depends on the question. 0.01, 0.001. We'll figure that out later. We'll work on that later. And then to get the function value there, we take whatever a plus h we've chosen and sub it in to get the y value. If on a scale of 1 to 10, you're about a 5 on there, you're like, I sort of get what you're saying. You are in wonderful shape because I'm going to do this like 1,000 times. Like I'm just going to keep doing this and doing this and doing this. Therefore, the slope of the secant looks really complicated, but this is the greatest thing ever. I'm telling you, what I built here is the greatest thing ever. It's y2 minus y1. F at a plus h minus f at a. And then the x values are a plus h minus a. And it simplifies nicely. A plus h minus a is just h. And this is something called the difference quotient. It gets a special title. To find the slope of a secant between any 2 points that are close together, find the f value at a plus h, subtract the f value at a, and divide it all by h. This expression is referred to as the difference quotient. It's going to go on the memorized board in just a second, yeah? Even though I can't remember anyone who forgot this thing by come test time, because now the next 2 sets of homework are just every single question, pretty much. You just write this difference quotient down and try to do the algebra. That makes it sound scary, like the algebra is going to be really scary here. I don't think it is at all. The algebra that we have to deal with here won't be all that bad. Here's what's happening in the picture. There's the slope of the secant. The slope of the tangent is the limit as that h value goes to 0. That's what we were doing. When we went 4.1, 4.01, 4.001, all we were doing is saying, get that gap down to 0. Head that gap towards 0. So, slope of the tangent will be the slope of the secant, but take your h value to 0. Take that gap towards 0. Head it closer and closer to 0. You watch. What's going to happen here is not 0.01, 0.001. We've got limits in our corner now. Yes? And so now the limits will take care of a lot of our problems here. Does this expression for the tangent slope take into account secant slopes for both sides? And the answer is yes. We were very specific about that. Limit as h approaches 0 means it has to be the same thing coming from both sides. So now you think back and go, oh, this is why he didn't get too worried about from both sides, because by the time the thinking finishes in calculus, this shows up, limits, and we go, this means it's got to be the same from the both sides. Now, what if it's not the same from the both sides? Actually, we just take that and we just punt that into chapter 3 for now. For now, we're going to go, the ones we're going to look at, they will be the same from the both sides. And then if they're not, we do that as a separate issue in chapter 3. So we'll just leave that on the shelf for now. So this definitely takes that into account, because when we say limit as h approaches 0, we're assuming the positive and the negative sides were the same. Some examples. All right, we're into examples here. If you sort of get what's going on, like I said, then we are in beautiful shape moving forward. Determine the equation of the tangent to the curve. Hold on. Find slope, then equation. Yes, when you see a question like this, you're like, find the equation. What do you mean by that? And we'll get to that in just a second. That's why we reviewed it in chapter 1, finding equations. For now, let's get the slope. And from here, for about, I don't know exactly how many days, 6 or 7 days, it says you want slope of tangent, so you write this, m tangent equals limit as h approaches 0 of f at a plus h minus f at a over h. And if it's a little mysterious looking, that's okay. We're going to learn about it right here. I'm going to draw a little picture here. of what's going on here. There's this point 4, -9 that we want to find the slope of the tangent at, or the instantaneous rate of change. This isn't a word problem, so it doesn't say instantaneous rate of change. It just says slope of tangent. And what I'm going to do is I'm going to go and get a second point out there, a little bit bigger in its x value than 4. And that little bit is called h. So there's this second point, 4 plus h, and then I have to find the function value at 4 plus h. Now, this is important. If you've drifted off to sleep, this is important. You've got a major question to answer is, am I going to make the a equal to 4 right now? Because I know it's 4. Or am I going to wait till the end and put the 4 in later? And I'm going to tell you, you're going to want to wait till the end. I'm not going to do that in the first couple. I want you to get to know how to do these first using like a 4 in there. And then later on, at some point today, I'm going to go, okay, or in the next lesson, I'm going to go, okay, enough. Leave it as an A because it's much more powerful that way. Okay, so we'll get to know that, and I'm going to mention that in every example. This one, I'm going to go with the 4, okay? And what I mean by this is that the limit is h approaches 0. We want 4 plus h minus f at 4 all over h. And I want to talk about this h in the bottom again, even though I'm going to stop talking about it. The reason it's a 4 is, look at, this point's 4, this point's 4 plus h. When I subtract, I get h. That's what makes the denominator so nice. Question?
So if we have 4 subs in grade, we sub in something close to 4 for h now?
Hold that question to a key moment, okay? Really just keep almost raising your hand on every line and go, now? Was it now? And then there'll be a big moment here where you go, oh, now I really like limits. Up to this point, on the weekend, I was home getting up, going, limits are killing me. And now in a minute, you're going to be like, oh, wait a minute, now I like limits. Okay, so the limit's going to take care of everything you're worried about right there. Okay, this is in the way. It's always in the way. Goes there. Okay, so look at me move the equal sign over. That's experience right there. I know what's coming here, and I'm going to need a little space for everything that's going to happen here. In some questions, it's more space. In some questions, it's less space. But I know in this one, I'm going to need a little more space. So I take the 4 plus h and sub it into the function. And I'm going to pause there and let you stare at it for a second so you can see what I did. I didn't deal with the f at 4. All I dealt with was the f at 4 plus h. I went back to the original function, and anytime I saw x, I wrote 4 plus h. It was negative x squared, so I wrote 4 plus h times 4 plus h. Plus 3 times 4 plus h, so I wrote 3 times 4 plus h. Or sorry, it was 3 times x minus 5. So I've just taken care of that f at 4 plus h. Then minus f at 4. What a mess, you say. Why is it negative in front? I'm going to highlight 2 negatives for you and hopefully crystallize that. Oh, smaller highlighter there. Oops, still smaller highlighter there. That is that.
In front of 4 plus h factored in.
Because this said negative x squared.
Right.
Good? This is a test of your algebra skills, not your calculus skills. The calculus here is just, the calculus is done right there almost. I got a little bit more calculus to do in all this, but it's just a matter, can I simplify this mess out? And now you're rewinding back to the grade 10, 11 version of you going, do all the algebra homework. You know, the algebra pays off here. And for most of you, you're going to like this because you can make the algebra pay off here. It looks long here, I'm telling you, the first time through. But as you start doing these, you're like, okay, you'll basically watch your hand do the algebra. Have you ever been doing math and you're just watching and your hand's moving and you're like, oh, wow, this is really good. This is going well. And you're just watching your hand do all the algebra for you. Okay, limit as h approaches 0. Just got to be careful with negatives and everything here. Let's see, 16 plus 4h plus 4h plus h squared. Do not feel bad about stopping me with algebra questions. The whole battle here is algebra now. The idea actually turns out to be not that difficult. You know, move the points closer and closer together. So the algebra is the challenge. Oh, I'm going to do that whole bracket together. Negative 16 plus 12 is negative 4 minus 5 is negative 9. And then some more tidying up to do. Things are getting better here now. And I'm going to scroll down here because I don't know how much. I want to put this all on one page here. Some more algebra. Negative 16 minus 4h minus 4h minus h squared plus 12 plus 3h minus 5 plus 9. I'm going to check that line. Felt like I got distracted there as I was doing that, so let me just check that line. Negative 16 minus 4h minus h squared, 12 and 3h minus 5 plus 9. And then the last line of the simplification, I think. Let's see. Negative 16, let me highlight those so you can see what I'm up to here. Negative 16 plus 12 minus 5 plus 9. Negative 16 is negative 4, minus 5 is 9, plus 9 is 0. Huh. All right, that's all right. Nothing to worry about there. Next is, I'll work on the h squareds. Okay, negative h squared. And then negative 8 plus 3h, I get negative 5h all over h. You're like, huh, that's sure simplified really nicely, actually. Sort of came down like it was a really big mess. And then by the time it was all done, it wasn't such a big mess anymore. It sort of played out there. Okay, one problem. I'm not done. It says find limit as h approaches 0. And what's going to happen if I sub in h equals 0 into this? Yeah, it'll be 0 over 0. 0 over 0, okay, that has a fancy name called indeterminate. But for us, in a beginning calculus course like that, what does 0 over 0, what's it really telling us to do? More work. Okay, what's the more work? And I look back on the board there. Here's some stuff we've learned about what to do when you get 0 over 0. If it's a polynomial, we factor. If it's a square root, we rationalize. If it's a cube root or more, we got that u substitution of going. If it's absolute value, we might have to go to a piecewise here. There's all these different strategies out there. Which strategy is this one? It's just factor. Yeah, this one's pretty nice. It's factor. Watch this. Equals limit as h approaches 0. There's a common factor in the top. You might choose negative h. You might just choose regular h. I'm not sure. That doesn't actually matter here, as it turns out. Negative h, and so I get h plus 5. Let me just look at that carefully to make sure I did that right. Multiply it back out, negative h squared minus 5h. After all these years, I still do it. Every time I do common factor, I immediately turn around and multiply it out in my head and go, did I do it right? Yeah, so I didn't make a little mistake here. And check this out. The h's cancel. As it turns out, h equals 0 is a whole, and a whole, we can still find the limit that it's heading towards. In a minute, I'm going to sub in h equals 0. You're like, wait a minute, you can't sub in h equals 0. H can't be 0. I'm like, I know, I'm just finding a limit. I'm finding out where is it heading towards. And this thing is heading towards five, not 5.1, not 5.01, nothing like that, actually towards the number 5. Question? Oh, yeah, sorry, negative does not cancel. Thank you. Negative, negative, negative. Good, negative. Whew. These are the little mistakes that are going to happen. This is the war now, is these little mistakes that are going to happen. And it's sort of good I made one up there so you're not too hard on yourself when it happens to you. But it would have been easy to drop this negative way back when. Easy to go, 8 plus 5 is 13, is 3 instead of 13. There's all sorts of things that will go wrong. It'll drive you nuts. But as you're practicing it, you'll get better and better at this. Okay, so m tangent equals negative 5. You might not be convinced that's more powerful than the old way of doing this. You're just going to have to go with me for a little while here. Just go on a little journey for about 7 or 8 days here. And by the end, you'll be like, oh, the difference quotient is where it's at. It's beautiful stuff. Any questions about that algebra, though? Let's go back and make sure we understand why h went to 0 here. You know, in all the algebra, you might have got lost as why h was going to 0. H was the little gap between these two. And as I headed h towards 0, those points got closer and closer together, and this limit was the slope of the tangent. Better yet, since h went to 0, it incorporates coming from both sides. So the limit takes care of all that. If you can sub in and get an answer, you've been coming from both sides. So that's all taken care of. And if you're on a scale of 1 to 10, if you're like, okay, I was a 5, maybe I'm a 6 now, I sort of, kind of get what's going on here, then we're in wonderful shape, because now I'm just going to do it again and again. And the next lesson, I'm going to do it again and again. I'm just going to keep doing it again. And I'm going to say a lot of the same catchphrases all the way through. So these little pieces of the puzzle, like what the heck is going on, by the end, now you go, okay, I'm starting to get what the whole plan is here. Do you need more time on that one? I got to keep checking the PowerPoint to make sure I'm doing the right example here. The next one was like a 2x cubed or something like that. Okay. Actually, let me give away what's going on in this lesson. I'm going to teach the difference quotient in every situation I can think of. I started with an x squared with a negative out there just to see, something degree 2 with a negative. Now, the next one I'm going to go is let's try and do it with a cubic and see what happens. So basically the same thing, but now with just a slightly more complicated function. And we're going to find that some functions are easy to deal with and some functions aren't very easy to deal with. Here it comes. You're going to write this 1,000 times. M tangent equals limit as h approaches 0 of f at a plus h minus f at a over h. And the picture of what's going on, which I'm going to include here, I don't know, I'll need some space for this one. This one's a little bit longer, so I might have to erase this picture later. But the little picture is, they've given me an initial point here, 2 comma something. And over here, I'm going to go to a second point, 2 plus h, comma, f at 2 plus h. And I'm going to send that, needs in the bracket there, I'm going to send that h to 0. I'm going to get these points closer and closer together as I go there. And this will be f at 2. Now, hopefully this gets repetitive. The things I say, hopefully you're like, he's saying the exact same thing in all these examples, because I argue this example is no different than the previous one in the idea of what I'm doing. The only thing that's different is it's got a more complicated equation. So the algebra will be a little bit different. So